The human body is, in its most fundamental sense, a carefully choreographed ocean. Depending on age, sex, and body composition, water accounts for between 55 and 75% of total body weight, a figure that shifts dramatically across the lifespan. Newborns begin life as strikingly fluid creatures, their tissues composed of roughly 75% water, making them physiologically closer to aquatic life than to adults. By their first birthday, that proportion has already fallen to around 65%, continuing its slow decline as fat tissue accumulates and body composition matures. What surprises most people is how unevenly this water is distributed. The brain and heart each hover at approximately 73% water, a moisture level comparable to a banana. The lungs reach around 83%, placing them closer to an apple than to any popular notion of a dry, air-filled organ. Even bone, dense and apparently solid, contains roughly 31% water. Muscle tissue carries between 70 and 75% water, while fat tissue holds far less, typically between 10 and 40%. Because lean tissue is far wetter than fat, a muscular person stores substantially more water by body mass than someone of equal weight with greater adiposity. Water is not simply something the body contains. It is a fundamental structural medium distributed through every organ and compartment in ways that continue to astonish even the scientists who study it. Water performs biological work far more sophisticated than simply keeping cells moist. It is the body's primary transport medium, carrying oxygen and nutrients to tissues while flushing metabolic waste from them. It lubricates joints and the membranes surrounding internal organs, preventing structural damage that friction would otherwise cause over time. It absorbs and releases heat with unusual efficiency, enabling the body to stabilize its core temperature against the constant fluctuations generated by metabolism and external conditions. Cerebrospinal fluid, composed almost entirely of water, cushions the brain against mechanical shock, delivers signaling molecules across neural tissue, and clears metabolic byproducts that would otherwise accumulate in harmful concentrations. Blood, which is roughly 83% water, keeps oxygen moving continuously to every cell in the body while removing carbon dioxide for expiration. Water is also a participant in chemical reactions, not merely a backdrop to them. It serves as the solvent in which thousands of enzymatic processes occur each second, and in certain reactions, it acts as a direct reactant or product. Without sufficient water at the cellular level, these processes slow, misfire, or stop entirely. Every day, the body loses between 2 and 3 liters of water through urine, sweat, bowel movements, and the invisible vapor carried out with every exhaled breath. These losses are not system failures. They are essential biological processes, and the body works continuously to compensate for them. That compensation is coordinated by a small, extraordinarily sensitive cluster of cells in the hypothalamus that monitor blood concentration with remarkable precision. When it detects that blood has become too concentrated, it signals the release of antidiuretic hormone, known as vasopressin. Vasopressin travels to the kidneys and binds to receptors on collecting duct cells, prompting water channel proteins called aquaporin to migrate to the outer membrane. Once in place, these channels allow water to flow passively from the forming urine back into the bloodstream, producing the dark, concentrated urine that serves as one of the clearest visible signals of dehydration. Research indicates that a loss of just 1% of total body water is typically compensated within 24 hours under normal conditions. When the body tilts toward overhydration, vasopressin secretion slows or stops, water excretion increases, and sodium balance is gradually restored. The entire process operates without conscious input, an elegant, self-correcting loop that runs continuously, whether the body is resting, exercising, or sleeping. Most people think of dehydration as a minor inconvenience, something resolved quickly with a glass of water. The biology tells a considerably more unsettling story. Brain imaging studies using MRI have shown that even moderate dehydration causes measurable reductions in gray and white matter volume across multiple brain regions. A body water deficit of just 2%, achievable by skipping fluids on a warm afternoon, impairs attention, psychomotor speed, and short-term memory. The dehydrated brain must work measurably harder to match the performance of a hydrated one, a cost that compounds invisibly across an entire day. A 2023 prospective cohort study, published in BMC Medicine, tracked nearly 2,000 older adults over 2 years and found that those with poorer hydration status experienced greater global cognitive decline. This makes consistent daily hydration one of the most accessible tools available for protecting long-term brain health. Overhydration carries its own serious risks. Known clinically as hyponatremia, it occurs when water intake exceeds the kidney's capacity to excrete it, diluting blood, sodium, and causing cells throughout the body, including brain cells, to swell. Athletes are especially vulnerable during prolonged exertion, when aggressive fluid consumption can overwhelm renal regulatory capacity quickly. Severe hyponatremia can produce headache, vomiting, and seizures, and in rare cases, leads to death. The old 8 glasses a day rule has been replaced by more personalized guidance. Current recommendations call for approximately 2.5 to 3.7 liters of total daily fluid for men and 2 to 2.7 liters for women, with those figures rising for people who are physically active, in hot environments, elderly, or managing certain health conditions. All beverages count toward that target, including caffeinated drinks like coffee and tea. Food accounts for roughly 20% of daily water needs, a contribution that is easy to underestimate. Fruits and vegetables are remarkably water-rich. Strawberries, cucumbers, and watermelon all exceed 90% water content. Eating them regularly supports hydration while delivering fiber, vitamins, and minerals that beverages alone cannot replicate. A diet built around whole plants is, in this sense, a hydration strategy as much as a nutritional one. A major study highlighted by the National Heart, Lung, and Blood Institute found that adults with elevated serum sodium, a marker of chronic mild dehydration, had up to a 64% higher risk of developing serious chronic diseases, including heart failure, stroke, diabetes, and dementia. They also showed signs of accelerated biological aging compared to better hydrated peers. Water balance is among the most accessible health levers available, one requiring no prescription, no specialized equipment, and nothing more than consistent daily attention to what the body already knows it needs.